U substitution. So the key with this method is whoops, sorry about that. The key with U substitution is your goodness, don't know what's going on here. You're trying to take the integral of something, but before you can do that, you're going to substitute something in so that you can take the integral, because you don't really know how to take this integral, the integral of this right here, as is. You have to substitute this for, you have to use what they call U substitution. So to the right, I'm going to show you what we're going to do. We're going to let U equal negative 2x. And then that would mean du dx equals negative 2. Okay. Now, yeah. what I like to do, I don't know how your teacher shows you, but I like to just solve this for du. Let's see, so, or dx actually. So that would mean that du over negative 2 equals dx. Do you understand what I did there?
Oh, just algebra, right?
Yeah, I just did algebra. I just moved this over and then I divided this over. And in my mind, it just kind of makes it look a little bit easier what I'm going to do. So anywhere that I see dx, I'm going to write in instead du over negative 2. So that's what that would be. And anywhere I see negative 2x, I'm going to write in u.
So e to the u times.
So this would be the same as e to the u times du over negative 2. And then I could rewrite that. I could take that negative 2 out front, then right as a negative 1/2. E to the u du.
Oh, okay.
And what's the derivative of e to the u du?
Just e to the u.
So I can evaluate this, and this would be just negative 1/2 e to the u, and then you should write plus c, right? Because it's you don't have the limits of integration. So that's your answer. Well, sorry. So then I rewrite. Now I substitute u back in, right? And u was negative 2x. So negative 1/2 to the negative 2x plus c would be your answer.
Okay, that makes sense.
Okay. Do you have the answer key for this, by the way?
Let me check. Yeah, correct.
Okay. Just make sure I'm writing it the way that your teacher wants you to write it. So for this next one, we're going to do the similar thing, right? We're going to say that we're going to let u equal 3x plus 1.
Why do you make it 3x plus 1 instead of like 1? Like, how do you
know? Because you don't know, you like in your head, you're thinking it's like a chess game. I know if I had like 1 over u, I know what the derivative of 1 over u is. It's just ln of u.
Oh.
I know what the integral of 1 over u is. So think of like the derivatives that you've done before. You want it to look like a derivative that you know.
Okay.
And the derivative that I know in my head, I'm thinking this. I'm thinking, oh, I remember the derivative of ln of x. If y equals ln of x, then the derivative is 1 over x. Right? So I'm thinking to myself, oh, look, if I can make this look like 1 over x or 1 over u du, then I know the integral is just going to be the natural log. Does that make sense?
Yeah.
So the derivative du with respect to x is just 3, which means dx, I'll say dx is going to equal 1/3 of du. So again, I'm going to plug this in for dx, and I'm going to plug this in for u, or I'm going to plug u in for that. I'm going to plug u in anywhere I see that. And then that way I'm going to rewrite this integral in terms of u. That's what I'm doing. So this is u, 3x plus 1 is u, and dx is the same as 1/3 du. Well, how I did that?
Yeah.
So if I pull that 1/3 out, because it's a scalar, I can pull that the factor out of there. It's just a number. I will have 1/u du.
Oh yeah. Okay.
Does that make sense how I did that?
Yeah.
Okay, and then now I know this. What's this? Remember, I'm thinking in my head, oh wait, I remember this. If I had, if
It just
the
went over.
derivative, yeah, what's the reverse of this? Like, what function has the derivative of 1/u du, and it's just the ln of u. So this just equals 1/3 times the natural log of u, which of course u, now I substitute u back in, and it's 1/3 times the natural log of 3x plus 1 plus c.
Oh, okay.
Okay,
Yes.
double check to make sure that answer is right.
Yeah.
Okay, so for this one, again, you're thinking to yourself, well, first of all, this should say dx here, right?
Oh yeah.
Okay, so I'm thinking to myself again, like, oh wait, look, there's cubed and there's cubed. And though, so maybe if this whole thing was u, if this thing here was u, then I would have u cubed, and maybe this would have something to do with the derivative of this. I'm hoping. So that's what I'm thinking in my head. It's a hunch I have. So I'm going to let u equal x to the 4th plus 3. And that means du dx. What would du dx be?
4x cubed.
4x cubed, which means dx, I like to rewrite. Well, actually, I'm not even going to write dx. I'm going to write du equals 4x cubed dx. Because do you see my x cubed dx over here? So now I'm going to take this 4 and I'm going to divide it. So 1/4 of du equals x cubed dx. And that's what I'm going to plug in for that when I see it. You see it there?
Yes.
So I'm going to even rewrite this just so you can see it. So I can rewrite this as x to the 4th plus 3 cubed times x cubed dx. And so now I'm going to plug in that thing right there. I'm going to plug this forward because that's equal to it, right? I'm substituting it in. I'm substituting 1/4 of du in for x cubed dx. Simultaneously, I'm going to substitute this in for u. So this is u cubed, right? You can see how I did that?
Yeah.
Which equals 1/4 integral of u cubed du. And now what's the integral of u cubed du? Now I can do this because that's just the power rule, right?
What?
If I asked you what's the integral of u cubed, what would you do? Instead of bringing this down to the front and subtracting 1, which is what you do, taking
It's
the derivative.
1/4 u.
Yeah, you're adding 1 and dividing by that new exponent, right?
Yeah.
So this is going to equal 1/4 times u to the 4th over 4 plus c, which equals 1/16.
Wait, what about du?
This, do you remember this? If I just asked you, if I asked you straight up, what's the integral of x cubed dx? What would it be? It would be x to the 4th over 4, right? Plus
Yeah.
c. That's all I'm doing because I have u. These are the same.
Okay.
Got it. And what's my u again? It's x to the fourth plus 3.
Yeah.
So x to the fourth plus 3 to the fourth plus c is your answer.
Okay. That makes sense.
All right, you're getting the hang of this, use substitution.
Yeah.
Okay, tell me what this says. Is that 1 minus 2x?
1
1
minus 2x squared.
Okay, 1 minus 2x squared. Okay, and that's cube root.
Yeah.
Okay, that's x and cube root of that. Okay, so again, what do you think we're going to name our u?
1 minus 2x squared.
Yep, we're going to name our u 1 minus 2x squared, which means what's du dx?
Negative 4x.
Negative 4x. Good. And now let's take a peek over here. What do I have? I have an x and a dx.
So you want to solve for dx.
Yeah, so I want to solve for x dx actually. I want to move the negative 4 to the left and the dx to the right. Because now I'm just going to substitute this in. So I'm going to even rewrite this again to help you see it better. 1 minus 2x cubed squared, sorry. And then x dx, I just moved the x over. And what was my x dx again? X dx is d, yep. So I'm substituting du over negative 4. And then I'm going to plug in that for u. So this is the integral of the cube root of u. Make sense?
Yeah.
You see how I'm doing it? I'm taking a little bit more time than probably your teacher would take. I'm actually showing you each step what I'm doing, but you don't have to. You can kind of take shortcuts if you want. Now I'm going to just take that negative 4 out, so it's negative 1/4. The integral of, I'll rewrite this as u to the 1/3 du. Right? And how do I take the integral of u to the 1/3? It's the same power rule as we had before. So add 1
u to the 4/3 divided by 4/3.
Yep, u to the 4/3 divided by 4/3 plus c. And then when we clean that up, that's going to equal that 4/3 flips and multiplies. So it's negative 3/16 u to the 4/3 plus c. And now I substitute u in there. Is your teacher okay with you writing fractional exponents?
Yeah.
Okay, sometimes they want you to write them as rationals. And this is 1 minus 2x squared, because that was what my u was.
Mm-hmm.
And there's your answer.
Okay, that makes sense.
Is that answer right?
Yeah.
Sweet. All right, what do you think u is going to be here?
X to the 4th.
Yep, I think so.
Or sine.
Nope, I think it is x to the 4th. Good guess. Because then du dx is going to be 4x cubed. 4x cubed, which means, do you see how I have x cubed and dx here?
Mm-hmm.
So I'm going to solve for that. So I'm going to say du over 4 equals x cubed dx. Make sense? And that's going in anywhere I see those two things together. So I can rewrite this as the integral of sine of x to the 4th x cubed dx. I'm going to substitute x cubed dx, which is right there. I'm going to substitute du over 4 for that. And I'm going to write out sine, but instead of writing 4x, I'm going to write what?
U.
The sine of u, that's right. So that equals 1/4 integral of sine u du. And
Mhm.
what's the integral of sine u du?
Negative cosine u.
Negative cosine of u plus c, which means it's
X.
negative 1/4 cosine of x to the 4th plus c.
Okay.
Make sense?
Yeah.
You have another one you want to tell me and I'll write it out?
Yeah, integral of x cubed divided by 1 plus x to the 4th power squared dx.
This is squared?
Yeah.
So did I write it right?
Yes.
Okay, so what do you think? What do you think it's going to be?
1 plus x squared.
I think so. 1 plus x to the 4th is u. And the reason I think it's going to be that is, can you see it right here? Do you see how that's the integral of that?
Oh, yeah.
That's another thing that kind of gives it away. So du over dx equals 4x cubed. So I rewrite this as, and I'm looking over here. So what I'm doing as I'm doing this is I'm peeking back over here and I'm seeing that. So I want those two things to be together.
So you're solving for dx.
Yeah, so I'm solving for like x cubed over, I'm sorry, x cubed dx. So I'm going to multiply the dx over. So it's x cubed dx on the right, and I'm going to divide the 4. So it's like that. Again, there's other ways that teachers teach this sometimes, but to me, that's the most straightforward algebraic way to make sure you don't make any silly mistakes. Got it? So when I rewrite this, I'm going to rewrite this as 1 over 1 plus x to the 4th squared. And then I'm going to write x cubed dx next to it. Just kind of rearranging it a little bit so it's easier for me to see that that is going to plug in right there.
Wait. Oh, okay.
You understand how I did that?
Yeah.
So this is du over 4. And then this is the integral of 1 over u squared u squared.
Yes.
And now rewriting that, I pull the 1/4 out. I leave the 1 over u squared in with the du. Or you could actually write it like this, u to the negative 2. Right? And what's the integral of u to the negative 2?
U to the negative 1 divided by -1.
Mm-hmm. Which equals negative 1/4, or negative 1 over 4u, we'll say, plus c. Got it? Which equals negative 1 over 4 times 1 plus x to the 4th plus c. And that is your integral. And by the way, you can check this by just reversing this whole process and take the integral of this now. I'm sorry, the derivative of this, and make sure you get to this.
Oh, yeah. Okay.
So you can check it to make sure that it works by doing that.
Mm-hmm. Okay, that makes much more sense.
Okay.
Yeah.
All right. Well, hopefully that helped out. Whoops. And whoops. Hold on. You there still?
Yeah.
All right. My wife just started calling in. So hopefully that worked out. And
Yeah.
hopefully this recorded on my Zoom